Good morning and welcome everybody to our fourth webinar of the Lynx project today. Very happy to welcome you. So my name is Martin Kaltenberg. I'm co-founder and CFO of the Semantic Web Company, one of the partners in the Lynx project, and you see it on the slides. We have what we have on the plate today on the agenda. So I will do a very short introduction about the Lynx project. We'll hand over to my colleague Artyom Revenko of Semantic Web Company to give you an introduction into the Lynx Services Platform. Which services do we have in place? And then we have a couple of speakers today that will explain the Lynx services, the smart services on compliance to you. You can see the list here. So this is Maria from UPM in Madrid. It's Julian from DFKI. In Berlin, we have Ruben from Tilde. Pablo also from UPM in Madrid, and then Ilan Kerneman, who is CEO of KDictionaries, speaking from Tel Aviv, and finally then Christian Sargeder, CEO of Cybly, also in Austria, located in Salzburg. We will have then a question and answering session. So if you have questions and questions come up to your mind, please put them into the chat in your panel of the webinar. You have a chat feature. There you can post questions at any time. We will collect them, we will put them together, and at the very end, we will open the floor to the panel with your questions. This webinar is going to be recorded for your information, and we will send out the slides and the recording in around 1 week in the coming days to all registrants and participants, and also publish that in our channels. So once again, welcome. I'm happy to start this webinar today on the Lynx Services Platform and the services. So a few words about Lynx. It's a project that started in December 2017, as you see on the screen, and we have 40-month duration. That means end of March, the project will finalize. And what is also interesting that you see, it's a project of the Big Data PPP. That means the public-private partnership that is between the PDVA and the European Commission. And the topic is cross-sectoral and cross-lingual data integration and experimentation. So a few words about the partners. You see we have several of them, and they come from all over Europe. And even we have one partner in Israel that works together with us in Lynx project. Important is what is the aim, what are the objectives. So the objectives of Lynx are to support European small and medium enterprises, SMEs, in their approach of internationalization in the area of compliance, regulation, and legal information. So usually when you're an SMA and you plan to expand into a new market, into a new country or region, then you have to take care about the labor law in this region, about the regulations that are in place, and so on and so forth. And Lynx has developed a set of services, of smart services, that support this approach, that SMEs can then really take a look at these different legislations, regulations from different countries available in different languages, and also you can make use of this so that compliance is becoming easier. So a little bit I said, but the mission is here summarized. So we have smart services to better manage this compliance. We will hear about these services in a minute. We have everything as a backbone is a legal knowledge graph. Here it's called LKG. And this legal knowledge graph integrates or has integrated legislation and regulatory data from all across Europe, from open sources, in some use cases also from closed sources, but the LKG is mainly open source, open data based. And yeah, it's multilingual. So we are dealing with multilingual data and information. And as I said, it comes from different jurisdictions all across Europe. So this was my short introduction about Lynx. And now we have to have a look if my colleague Artem is in the call to take over. Artem, can you hear me?
Yes, can you hear me?
Yes, we can. I just stop speaking. The floor is yours. Please tell us about the Lynx Services Platform.
Thanks a lot. So our wonderful Lynx Service Platform features many different services that, well, actually 16. And we split them into different categories. And I will give a very short overview of those categories. And then we will go into details of each category, and we will have examples of some services presented by different partners. First, there are 7 services that produce enrichments to the incoming documents. Of those, 5 produce different annotations in text, and 2 convert the whole text of the document into something else, something like summarization or machine translation when you translate the whole document. Then we have 4 services that are dedicated to search and information retrieval, 2 services related to vocabulary data, and 3 basic platform services that enable the functioning of all those services together in workflows and in a secure way. We have this nice page where you can go and have a look at all the different services and additional informations such as small demonstrations, videos, or their open API description. Next slide, please. Yeah. And now we would like to start with annotation services. We have 5 of them. Those are temporal expressions, geographical named entity recognition, more general named entity recognition, relation extraction, and entity linking. Next slide, please. And here I would like to pass the word to Maria.
Okay, thank you, Artem. So I will present the first of the annotation services in Lynx, that is the temporal expression service. In this service, we annotate the following type of expressions: dates that are calendar expressions like April, full dates like the 23rd of May, or years, 1998, but also relative expressions like yesterday, 2 days ago. We also annotate clock expressions. We call times like 2 o'clock, 5 p.m. Any format you can imagine to give time. We also can find sets that are very important in the legal domain. These are expressions that repeat over time, like Thursday, twice a month, yearly. We also identify durations, also composed ones like 2 days, 2 days and a half, 3 years and 3 months, and so on. And we are also working on detecting intervals. That it's something that it's not covered by state-of-the-art temporal expression services. So we are able also to find intervals like from the 3rd of April to the 6th of May, from 1 to 2, and so on. Next slide, please. So once we detect these expressions, we do what we call normalization. This is give a standard value to each of these expressions. So for instance, in this sentence, in 1998, it increased exponentially, and that summer something happens. The first expression, it's straightforward, it's a year, so the standard value is 1998. But the second one, that summer, okay, from this excerpt, that summer, we can derive that it's the month, it's summer, of course, the season of summer. But from the text, from a previous expression, we can also derive it refers to a specific summer, namely the summer of 1998. So our task is also to anchor this expression to a calendar, so it can be used for further application. So the normalized value here would be summer of 1998, that we express 1998 SU because it's an ISO standard to represent dates. Next slide, please. So this is what the temporal expression service does. And we cover the following languages. For Spanish, English, and German, we have developed a dedicated approach to the legal domain, a rule-based approach that are able to cover also some legal expressions that are not covered by state-of-the-art taggers. For English, it has been developed by UPN, and for German, it has been developed by DFKI. And we are also able to identify expressions from Italian and Dutch text, but for these languages, we don't have a legal development. We use a state-of-the-art temporal tagger that it's an external tool. So if you want to know more about this service, please check the Lynx YouTube channel, that among our nice videos, you were able to find a demo and more information about this service. Thank you for your attention.
Thanks a lot, Maria. And next, we would like to have a look at named entity recognition services presented by Julian from DFKI.
So thank you very much, Artem. Yeah, I will try to give a short or small overview about the name entity recognition services. These are two, the general domain one and the geolocation that will come after that one. And probably most of you will know, but always a small introduction is nice. What is the goal of the recognition of name entities, or what are name entities? So mainly when we talk about name entities, those are proper names about cities, persons, organizations, like Paris, Berlin, Barack Obama. These are common examples, and this is interesting to identify because then with this starting point for the natural language processing tasks, we can go further and use this information to start more complex processes as event detection, relation extraction, and many others. In the Lynx project, for the general domain, we have focused on 4 different approaches or model families that are statistical language models. Those are the simplest ones. Then an improvement on that ones that are the BERT-based neural networks. These 2 model families are focused on generic Wikipedia training data, so generic and general domain, while the 3rd and the 4th, those are the conditional random fields and the bilateral long short-term memory neural networks. Those are specifically trained for the legal domain. That is the interesting and the focus of the Lynx project. In that case, due to the lack of specific training data for such a system, we focused on generating a German core decision corpus manually annotated that was composed of 67,000 sentences and 54,000 entities divided in 7 coarse-grained classes that are then subsequently split in 19 fine-grained classes. Please, next slide. Here we have a brief overview of the different classes because that was a hard word to define which classes we can define because this is completely domain specific, in this case for the legal domain, that is the focus. And the different fine-grained classes were manually defined and then checked by 2 other annotators in order to have a good coverage of the different entities that could appear in the legal domain. This corpus was used to train the 2 specific legal models for the German language. Next slide. Now, as a next step, we went to the development of a specific service for the identification of geolocation entities. Those are generally part also of the name entity recognition system, but in this project, we decided to split it in a different service because locations play an important role in legal domain. For example, if we think about the analysis of contracts, of rent contracts, it's quite important to define where the object is located. And this service focuses on that. And in that case, we have specialized the service in order to use also a dictionary-based approach and a rule-based approach that allows us to identify specific entities such as companies from a Spanish dictionary or specific addresses using regular expressions. Next slide. In order to train the language model, we also used a manually annotated corpus that can be partially seen in the slide, that it's composed of 17 fine-grained classes for locations that are not specific for the legal domain, but this is still something that we are improving and further developing. Next slide. Here we just included the regular expressions that we defined for the addresses, just in case that somebody wants to replicate or use them in other approaches. but just to say that they are working quite okay, but there is still some space for improvement regarding regular expressions and legal domain and legal documents at least. And that's it from my side. Thank you very much.
Thank you very much, Julian. That's really cool that we are trying to recognize entities using different approaches. This makes the whole service more robust. Now I myself going to give a short overview of entity linking and our specific entity linking. You will see why the task is a little bit special in our case. First, we would start with a general understanding. So what we try to do with entity linking. On the right-hand side, you can see those pictures, and on the very right, you see the sentence. BMW has designed a car that is going to drive Jaguar X1 out of the market. So the task would be to connect all the entities that appear in the text to entries in a knowledge base, to concepts in a knowledge base. And this is the usual task statement when you expect that for Jaguar, you would be able to find all the relevant senses in the knowledge base. This is usual setting. This is used for large knowledge bases that cover almost anything when you work with something like DBpedia or WordNet. However, for the legal domain and for the legal knowledge graph, we are focusing on the legal terminology only. Therefore, we would not have such general purpose senses as animals or anything else. Therefore, we would not be able to see all the possible senses of the word. Therefore, we relax our assumption, and what we actually want to do, depicted at the right bottom part of the picture, is that we only have one entity representing Jaguar in the knowledge base, and we would like to disambiguate if the one that we find in the text is the correct one. So in this particular example, it is incorrect because we have animal Jaguar in the knowledge base, and we have Jaguar as a car in our text. So in frames of the Lynx project, we have developed a service that is able to tackle this task, and that is able for each mention to correctly disambiguate if that one is meant in the sense of our knowledge base or not. Good. That's for the entity linking service. And now we go to the next category of services, which are conversion services. Here we have machine translation and summarization. And we will start with machine translation. And here I'm glad to pass the word to Ruben from Tilde.
Thanks, Artyom. Before we dig into the details of the service within the Lynx project, we want to give some background information, because nowadays we think of machine translation of Europe, of the differences, and at the same time the similarities. But nowadays the fact is that language continues to be, to a certain extent, a barrier within the European borders. And in here we just wanted to bring some details and some figures on the fact that, for example, 6 out of 10 or every 6 people out of 10 people in Europe don't speak English well to hold a proper conversation. Or the same as nowadays we see that e-commerce gains momentum in the current circumstances. We see that 4 out of 10 Europeans, according to the statistics that were released from the analytical report last year, don't purchase products or services if they are not in their native languages. This is a significant data. This is significant information, and gives us a good input in order to move further. Next slide. We can see that what are the benefits of machine translation. So basically, when we talk about machine translation, this is a tool that helps to increase efficiencies, reduce costs, increase productivity, and at the end of the day also reduce barriers when it comes to languages. We talk about internal, external communication, and then also entering new markets where this is not the language that or our native language. So if we go to the next slide, we focus now on machine translation in Lynx. This is service that is provided externally with the state-of-the-art technology, which is based on a neural machine translation technology. What does it mean? This means that the technology itself, the service, machine translation, is based on a similar way on how the brain works. And this helps to provide more accurate translations to what a human would give, also within terminology. And this is provided within also up-to-date platform in terms of technology, which also provides regular technological updates. This tool provides the opportunity to translate source documents, text, snippets, and annotations. And this is provided within a very simple and user-friendly interface with the source text to the target text. Within this project, we see and we talk about use case specifics and languages. We talk about contracts, labor law, the legal domain, and then also the renewable energy specific domain. These machine translation systems models, language models, have been trained with a combination of Tilde's extensive library and then also the data available from Lynx partners. And that provides a more accurate and specific and qualitative translation for those specific fields.
Thank you very much, Ruben, for this overview. And now we are back to Julian with summarization service.
Thank you, Artem. Yeah, this is another important part that we have been developing in the Lynx project, because being able to have a long document, what normally on the legal domain is quite common, and obtaining automatically a small summary that can provide an overview of the document is a crucial part. If you want to understand, let's say, 100 legal documents in a short period of time, then you really need such a system that could extract the most important information from the document and then provide a kind of structured and logical text that you can read. In that sense, we have tried two different approaches. The first one is the extractive summarization. And what does that mean? That is an approach that get a document, extract sentences or part of the source text, and then combine them in, let's say, logical and proper way to generate a good text, but using the source text for it. In that case, we have tried two different approaches, one using the TF-IDF approach, the term frequency, inverse document frequency, to detect which sentences are more important on the documents. And then a second one that is based on centroids, where we compute the centroid for the whole collection of documents, and then we a centroid for the document, sorry, not the. And then with this centroid for the document, we try to find the sentences that are nearer to this centroid. Next slide, please. On the other hand, we have a second approach that it's an abstractive summarization approach. In this case, the idea is not getting the source document and extracting sentences from it, but analyzing the document, understanding the meaning, and then based on the meaning, extracting the most relevant sentences, but rewriting them. So generating a kind of a new text, not using the source text, but keeping the meaning and generating a new whole piece of text with this semantics behind. In this sense, we focused on the usage of transformer encoders that convert the text into embeddings, and then they go through a set of deep learning and neural network approaches and try to extract the meaning of the sentences and then find the best fitting sentences, and then afterwards converting or reconverting these embeddings into new text. That's only usable if the documents are of a maximum length based on the available technology currently. And for longer documents, we are combining both approaches. First, we apply an extractive summarization, getting a long summary, so to say, and then this long summary is summarized again with the abstractive summarization that provides a new text that it's more beautiful than just getting a kind of set of sentences from the original document. And that's it for the summarization.
Thank you very much, Julian. And now we are going ahead with the search and information retrieval services. Here we have a group of 4 services, and we would like to jump into cross-lingual search that will be presented by Christian from Sibley. Please, Christian.
We have created a cross-multilingual search. We have APIs for adding and deleting documents out of the index, and we're working with our Lynx documents. And based on this index, we then provide a search functionality for the documents. We have the possibility to create complex queries with and or not must. Also, you can provide near functionality. You have phrases. You can even put it into brackets and so on. In addition, you can filter your queries, for example, for certain document types or even for certain metadata, which is provided within the metadata field of the Lynx documents. And based on this query, you create then a translated search query will be created, which is then used to create index. To give you a little bit more how the whole system of the search is working, we go to the next slide, please. So what we are doing, so if you write in, for example, our example sentence, maternity leave in Spain and Austria. So if you want to have information for this, for Spain and Austria, the first thing is we try to detect the language you have created the query. In this case, it would be English. In a second step, we use already Lynx services to extract information out of this text. In this case, we try to find with geo or named entity recognition and entity linking information. So we're getting, for example, Austria, Spain from the geo services. In addition, if in the knowledge graph there would be maternity leave, we would even retrieve this information that there is an entity out of the knowledge graph. Based on the languages we are detecting, the geolocations we detected, we try to get the jurisdiction you want to search for. Here in this case, it's the jurisdiction would be Austria, Spain, as we have looking for Spain and Austria, and in addition, European Union, because it could also be that there is a European regulation for the maternity leave on top of it. And we know that for this jurisdiction here in Austria, for example, we have German, in Spain we have Spanish, and on the European Union we can use the original language English for the query, as the European texts also are provided in English. Based on this, now we create a syntax tree, and this syntax tree is then translated to the different jurisdictions you have. And if you look now below, you will find something like, this is also not the final query, but this is something clearly there, that you will find that we have a query for Lesina and in Spain, Karenzzeit and jurisdiction in Austria, and maternity leave and jurisdiction for European Union. And in this way, we find all the related documents, even if you were searching for in another language than the corpus of the document is. So we prevent with this the translation of all the different corpus, which makes takes too much time. Thank you.
Thank you, Christian. And here, as a bonus, we have an overview of our citizen portal, presented by Pablo from UPM.
Thank you, Artem. In the context of this project, we have also created a document search service for information retrieval tasks. It's presented as a user-friendly web portal in which you can ask for different words or terms that and also you can filter with different types of parameters, such as the type of the documents, the jurisdiction, or the language. But internally, it works also as a RESTful API and can be consumed by other applications. This service relies on an Elasticsearch document manager, and which can handle parts of document as independent ones in the search process. Next slide, please. The parameters of the search query can be words, terms, collections of the documents that are stored, jurisdiction, language, and parts of another document. Also, in this context, we have evaluated our service, and we are still evaluating with a gold standard created by the Quatre Casas. This gold standard contains 152 questions related to specific articles of the Spanish Worker Statute. We have achieved very, very good results, and we're still doing experimentation with Elasticsearch, with the estimation process, using synonyms, or even giving more weights to different terms that could be presented even in the query or in the document. Next slide. Thank you.
Thank you, Pablo. Thank you. As you can see from the presentations by different partners, though our services are already online, we are still working on improving them and making them even better than they are now. And now we would like to go into the last category that we would like to overview for today, that is vocabulary services. And here we would start with dictionary services presented by Ilan from KDictionaries.
Thank you, Artem. Hello, everyone. The dictionary services are part of the domain-independent vocabularies to distinguish from the domain-dependent ones of the terminology in the legal domain. So we have data which is fairly rich linguistically. The formats are originally in XML, going into JSON for API and JSON-LD for linked data RDF. The endpoints possible are through Sparkle and through the Lexicala API. And we are dealing with the 4 languages of Lynx: Dutch, English, German, and Spanish. Next slide, please. The entry components are quite varied. As you can see here, I'll just go over it quickly. There are headwords, multi-word expressions, inflected forms, variants. There is the phonetic transcription, alternative script, part of speech, grammatical gender, number, grammatical subcategorization, valency. Then there are definitions, sense indicators and disambiguators, examples of usage, synonyms, antonyms, subject domains, the context, range of application, registers, sentiment, and geographical usage, and of course, translations. Next slide. Here you can see a reader-friendly traditional entry. This is a Dutch word, and you can see it has 2 different meanings. One is an arch, the other is bow. So each one is distincted by a definition, by the specific translation, supported by example of usage. And there is also a multi-word expression, which is below, and you could read yourself. It has nothing to do with neither bow nor arch. That is part of the language mystery. Next slide, please. So we go through a certain pipeline to turn it into RDF data. The data is modeled with Ontolex, which is de facto standard for ontologies and lexicography. So Originally, the data is in XML. For the API, it goes into JSON, and then it is converted into JSON LD. Our approach is incremental. We map the XML path with corresponding LD elements. There is the URI naming strategy, implementing the model and having it validated. Next slide, please. This is what it looks like graphically, the same process, which I have just explained. And one more slide, please. So just to show you the results here of a sample query, this is the word bow in English. And basically, as you can read here, we have 56 possible options here for bow and for bow, which are two different nouns in English, as well as to bow, the verb, and wherever bow appears in the definitions or in translations to other languages. That's it. Thank you very much.
Thank you very much, Ilan. And now we would like to finalize with the terminology service presented by Pablo.
Hello. So also we have created a service to show specific terminologies created in the context of the project. These terminologies are domain specific and have been created from different corpus of each of the pilots: labor law, contracts, and industrial standards. We have used different NLP tasks, and we have generated a multilingual rich terminology by reusing also knowledge that is available in the linguistic link open data cloud. Also, finally, the terminologies contain terms, translations, synonyms, definitions, contexts, and broader and narrower relations. They can be consulted through this Lynx terminology portal or queried through the Sparkle endpoint. Thank you so much.
Thank you very much, Pablo. So Artem, if okay, I will take over here once again. Yep, here I am. Thank you very much to our speakers, and thank you also to be very precise on the point. So what I want to tell you, because you heard a lot about services and you have heard a lot about also our pilots, but we didn't introduce them because we already had webinars on our 3 business cases. So what you see here is today we are closing this webinar series of Lynx. It's the 4th webinar, but if you're interested in digging deeper into the topic of Lynx and into the business cases, so to see what have we done with these services, how have we combined them into real-world use cases, just go to our YouTube channel and have a look at the 3 business cases on top of the Lynx legal knowledge graph. It has been mentioned, we have 3 of them, and then you can really see very nice demos and introductions how we combine the services into real-world applications, where one is in the area of labor law. It's a question answering engine in labor law organized by our partner Quatre Casas. The second one is about contract analysis and management. This is by Cybly. So Christian, you saw Christian before. So Christian implemented also a use case in that area. And the third one is implemented or organized by our partner DNVGL. And it's about geothermal energy domain and how you can support compliance in the geothermal energy domain all across Europe. So this can be very interesting to combine the dots that you have seen today, because today we were very technical and on the point on the services. And as Artem also showed at the beginning, we will send the slides. There's a very nice link where you can go to the overview of all the services. You can have a look at the documentation, on the descriptions, on small demo videos, and you even can you can try out the APIs available on this API page for all the Lynx services. So I would recommend to go into this direction. Before we go into the question and answering session, also one remark, because we had it before. So in principle, you have seen we're working in 4 languages and we are working in the legal domain. In principle, these services are generic. So if you use another knowledge graph for another domain, let's say the health domain instead of the legal domain, you can also easily adapt and train the services on another domain. And it's also, let's say, generic in regards to languages. We have trained services and we're working with 4 languages, but it's relatively easy to expand also the number of languages to more and more languages. So if you're interested in that area, just get in touch with us. We're happy to discuss together with you. So I'm going into question answering session. So I would like to ask all our speakers and panelists also to turn on your camera where possible, because I think then it's nice. We can see your faces and we can also have a look when I hand over a question. Then it's nice to see who answers this and who you are. Hi again. So first of all, thanks to all of you. That was a really very nice run through the services in your presentations. I'm getting the first question. I think we have time for 2 or 3 of them. And one is relatively clear. It says here, it's a question to Ilan from KDictionary. It says, okay, how many languages or what resources has KDictionaries in place beside the ones that you have mentioned? So if somebody is interested in more resources, can KDictionary provide these? No, we cannot hear you. Oh, I cannot hear you.
Sorry.
Yeah.
Yes, indeed. Our company is from the old world, as the name shows, KDictionaries. That is a bit anachronistic now in this century. But basically what we do is develop language resources for different languages. We cover about 50 languages. We have resources for nearly all the EU official languages. Maybe it's interesting to mention that the 4 languages we are dealing with were selected particularly for the 3 use cases that Martin has just mentioned. And these were the languages that each of them concerned, namely Spanish, German, and Dutch, plus English as a lingua franca here. So yes, we have resources for more languages. What we do is we go and dig in to try to map the DNA of each language. And once we have that, we map it. We categorize the components of the language, link them to each other, etc. Once we have that monolingual dimension, we can link it to other languages and create a certain cross-lingual network with that.
Thank you very much, Ilan. Very good explanation of what is there. If you're interested to learn more about, I guess the easiest way to get in touch directly with Ilan and KDictionary. A second question, this one is for Maria. It's about Timex. The question is very technical. It says, why are you not using, or are you using deep learning?
Well, we are not using deep learning because it would require an amount of corpora that it's not available. In English, there are some corpora available, but not big enough and not in the legal domain specifically, so it's not useful. And for Spanish and for German, there are even less corpora available.
Thank you very much. We're on the point and good explanation. I think we can take more, but let's have one. That's to Ruben. It says machine translation. There are also publicly available services. So why shall I go for Tilde? What's the difference, or of what you have presented?
Thank you very much for the question. So yeah, basically for those publicly available resources, those are very generic options. And then in terms of the quality, in here we have a very user case specifics with specific data for those particular domains. And then of course there's one of the main topics when using freely available resources, which is the security topic. In here we talk about platform which is highly secure, and when using freely available resources, then there's a question mark on that topic.
Thank you very much, Ruben. Good. If you have any questions, we see we have lots of people here in the webinar. Just drop them into the chat For the moment, we don't see them. Otherwise, in the meantime, it's relatively easy. So maybe my reminder, this webinar is recorded. We provide recording, we provide the slides in the coming days. So you can have a look at this. There's also contact information in the slides. There's information for follow-up information where you can go to the APIs, where you can have a look at other webinars. And I think at the moment it's good. So I think we're good to go. So I would like to thank, and I go through all the speakers for this webinar today on the Lynx services. Thank you, Maria, Pablo, Ruben, Christian, Ilan, and Julian, and Artem that we cannot see, but I know he's on the call. And also thanks to Thomas, who is always helping us behind with a webinar software and is organizing all these things. And also thank you very much for all the participants for your participation, for taking the time, and stay healthy, stay safe these days. Take care. Have a great day. Thank you and bye-bye.
Bye-bye.
Bye.
Bye.